Hi, this is part 4, week 3. For this, we're mostly just gonna do this together. I'm not gonna be asking you to pause and do work, just because it's sort of a new process that I'm gonna be walking you through. All right, so yet again, we're gonna have to pretend we're doing something fun and engaging, but we kind of can't, so sorry. Yeah, not my favorite. Okay, so we're gonna be discovering how much of the earth is covered by water. I'm sure some of you kind of know this or you know where to find that information, but we're gonna pretend we don't actually know. Okay, so what proportion of the earth is covered by water? We're gonna investigate this question by pretending to take a random sample of locations on the globe. So last year what we did is we actually had a globe and then people would like randomly point to a bunch of spots and then we would say like, okay, yes, it's water, or no, it's land. All right. So in our pretend sample, and I filled this out for you already, let's say we did 50 samples and that 34 of them landed in the water. Okay, so question 2 is asking you to calculate the proportion. So based off of these numbers, 34 out of 50 were samples landed in the water. Converting that to a decimal, I'm going to get p hat is equal to 0.68. All right, so question 3, I'm asking, there's this whole process here, which you can see. It's state, plan, do, and conclude. And what this process is how you construct a confidence interval. We'll put this in your notes in a bit too, but I think it's helpful just to like see an example first. So just stick with me, fill it out as we go. I'm not gonna, well, there might be a few points where I ask you to like do some calculations or something, but for the most part, we can just do it together. All right, so first of all is the state section. So we have to state the parameter and the confidence level. Parameter is what we're trying to find out. So here we're trying to find out the true proportion of earth covered in water. And the confidence level, usually a problem will just tell it to you, which it does here, 95%. So we just have to state that. And that's it. That's our first step. Great. That wasn't too bad, hopefully. Okay, next up is the plan section. Here we're going to identify the appropriate inference method and check for conditions. There's a few different procedures that you're going to learn by the end of the unit. Right now we only know one of them, which is the one sample Z interval for P, and remember P means proportion. Once you get onto the AP classroom, the first couple questions are asking you like, which process or which procedure do you need for this? All of them, it's this, because that's the only one we've looked at so far. By the end of the unit, there are, I think just like 2, maybe, and then in the next unit we learn a couple more. Don't remember exactly, but for now, this is the only one. So when you do your part A multiple choice practice, just look for the one that looks like this. All right, checking conditions. We have 3 conditions to check. We went over these in our notes, not yesterday, but in the last part. So first of all, we have to check for random. And yes, we had a random sample of 50 locations. Okay, check for 10% condition. So we have 50 locations that we randomly chose. That is less than 1/10 of all locations on Earth. And then, so that one's good. And then the last one is large counts. For large counts, we want to see if we're going to have at least 10 successes and at least 10 failures. So based off of our sample, we had 34 of our samples were covered in water, and that's greater than or equal to 10. That means we had 16 that were not covered in water. That is also greater than or equal to 10. So all 3 conditions have been met. All right, the next section is like the mathiest looking section. So if the conditions are met, which they are here, we can go ahead and perform the calculations. First thing is that we need to write out the general formula. And this is going to be the same for regardless of whether you're looking at proportions or means. It's always going to be your point estimate plus or minus your margin of error. On an FRQ, it is important to write this out every time. So that's our general formula. Next up is the specific formula that we're going to use. And here we only know one formula. We're just going to use that one. It's going to be your point estimate plus or minus Z star. And then big square root P hat 1 minus P hat all over N. Next step is plugging numbers into this formula. So our point estimate was 0.68. I'm going to do plus or minus. If we're looking for a 95% confidence interval, that was one of like the common ones I gave you. So if you wrote that down, you have that value. Otherwise, you can do inverse normal and figure it out. Here we go. But since I just showed you, we can write that down. So 1.96, big square root, and then I'm going to do 0.68 times 0.32 all over 50. Also, I just want to say, and that should all be under the square root. You can type all this into Google Docs. You can also like use a sketch and like insert a drawing and just write it out. You could also like open up like a Desmos screen. Desmos is, I think, a little easier to type out formulas and stuff. And then you can screenshot that in. So you have a few options there. Don't stress too much about the formatting. All right, so for my answer, let's see, I'm just going to bring down my 0.68. This whole thing here simplifies to 0.129. So I'm going to do 0.68 minus 0.129 to get my lower bound, so 0.551, and then 0.68 plus 0.129 to get my upper bound, which is 0.809. And so that's my answer. That is the confidence interval. So the last step here is to interpret it, is to conclude. So what I can say is we are 95% confident that the interval from, and just like a lot of the interpretation questions, once you've seen it a few times, it just becomes like a fill in the blank. 0.551 to 0.809 captures the true proportion of earth covered by water. And some of you probably know this, like I said, or you looked it up just for your own curiosity's sake. The true value for P would be about 71%, which that fits right in there. So we weren't wrong, right? Like our true value is within that interval. All right, so we've got a couple things to cover in notes. One of them is just going to be kind of outlining this process. And then the second one, there's like a certain kind of problem that you'll sometimes see regarding this. And I just want to show you how to do it. So first part is the 4-step process. And this is just going to outline what we did in the activity for part 4. So state, plan, do, and conclude. So for state, you have to say what your parameter is, what you're actually looking for, and your confidence level that you're looking to create. For plan, you have to name the procedure and check conditions. For the do section, you need general and specific formulas. And then you're going to plug numbers in and calculate your interval. And then last step is for conclude is just your interpretation. If you need examples on that, you can always go back and look at the classwork we just did. For the first few times I ask you to do this, I'll kind of outline the steps for you. But then as we move forward in the unit, it'll be more just like construct the interval. And you're just going to have to remember, okay, that means I have to state and plan and do and conclude. All right, the other thing I want to talk to you guys about is there's a certain kind of problem that you'll see sometimes where it asks you to choose a sample size. So I'm just going to show you how to do that. You will see this in the check for understanding. So in this kind of a problem, you're going to be given your margin of error. And then you're going to have to plug in your Z star value, your P hat, and then N is going to be unknown, and you're going to have to solve for that. And then there's a couple other notes here. When your P hat is unknown, you can use 0.5 as a conservative calculation or conservative estimate. And then the other last note here is if N is a decimal, round up. Okay, so I want you to go ahead and, write this down or do whatever you need to. I'll also post it like I have been. I want you to try the check for understanding. When you're ready to go over it, you know what to do, but please do try it. Otherwise, you're not going to get anything out of it. You're just going to sit here and watch me do it, and it's really boring. I want you to try to use your brain, solve it, get as far as you can in the problems, and then we'll go over it when you're ready. All right, so for question 1 here, it's asking us, okay, using a conservative estimate. So in our notes, we know that means we're going to use 0.5 for our P hat. And we're trying to figure out, okay, how large of a sample do we need? So I really just need to have one problem per slide. That would just make my life a lot easier. All right, so this is check for understanding number 1. All right, so the equation that I gave you in notes is your margin of error is equal to Z star, and then big square root P hat, 1 minus P hat all over N. So we're gonna plug in what we know here. In the problem, it tells us our margin of error. Great, 0.02. It tells us it's a 95% confidence level. The Z star for that is 1.96. So you might see, I know in the last part I told you might want to write these down. There are some very common confidence levels, and if you can just have them, then you don't have to even grab your calculator. You can just be cool, 1.96. All right, using our conservative estimate, P hat is 0.5. 1 minus 0.5 is also 0.5, and that's all going to be over N. Now we just have to solve for N. And some of you, I know, are just going to see that and be cool, I know what steps I need to do. Some of you are going to need to really just go slow and make sure your algebra is right. So I'm trying to solve for N, so I'm trying to get N by itself. My first step, I'm going to divide by 1.96 on both sides. All right, and let's see what that gets us on the left. So I'm looking at 0.010204. Usually if I'm in the middle of a problem, I won't round, and I'll wait to round until the end. And then on this side, I have, 0.25 over N. I got the 0.25 just by multiplying out this numerator. Okay, next step, I have to square both sides. Okay, so on the left, now I have 1.041, but it's times 10 to the negative 4 power. I'm just going to keep it like that for now, because I'm still going to have to do some other work to it. And then on this side, I don't have the square root anymore. Okay, so now if I'm trying to get N by itself, I'm going to have to multiply by N on both sides. That'll cancel it out here. And then I'm going to have to divide by this really small number on both sides. And I'm kind of just running this calculation on my calculator, I'm not clearing it out or anything. But so my final answer, let's see, these will cancel. Then I'm going to do 0.25 divided by that denominator. And if you're doing all of that stuff right, you should get your sample size of exactly 2,401. Question 2. In the petition, 85% of the signatures were valid. Using this as a guess for p hat, find the sample size needed. So we're going to be doing a similar process here, except for now we have a different p-value. So yet again, I'm going to insert another blank slide. Okay. So if that, for number 1, if that was a little fast, we're going to go over a very similar problem, same kind of algebra steps, but you'll just get to see it again. So my margin of error is still 0.02. And then it's still a 95% confidence level, so 1.96. The only things that are changing is what's under the radical. So I've got 0.85 and 0.15, all divided by n, and we're trying to solve for n. All right, so first step, I'm going to divide by 1.96 to start to get n by itself. Okay, so then on the left, I'm getting 0.010204, same number actually as in number 1 so far. And then I still have this big square root. The numerator inside that square root simplifies out to 0.1275 all over n. Cool, I'm going to square both sides. Then, let's see, 0.02. Cool, then on the left side, I have 1.0412 times 10 to the negative 4th, which I think is the same exact, yeah, same thing. Then on the right side, I don't have that radical anymore. All right, cool, so now I just have to get n by itself. So I'm going to multiply by n on both sides. And I'm also going to divide by that really tiny number, 0.0412 on both sides. Okay, and then I can show you how to do this on your calculator too, just because the numbers are a little weird to work with. What we should be getting here is our n is equal to 1,224.51. In the notes, I told you that if n is a decimal, you have to round up. So that gives us this for our final answer. And then it also asks you how does this compare? This is much smaller. Okay, so I'm going to jump over to my calculator just to walk you through. I don't want to sign in. How just to do these calculations because they're a little bit clunky. Okay. So when I was solving this, I started by doing 0.02, and I'm going to show how I did number 2, divided by 1.96. That gave me my first number I was working with. From there, I had to square it. So then I didn't type the number out. I just hit the square button, and then you'll see it says answer squared. That means it's going to take your previous answer and square it. Okay, cool. And then from here, I had to do 0.1275 divided by that number. I don't want to type that number in because it's sort of annoying to type in. So what I can do is if you look down by the negative key, there's something that says ants. I'm going to do second and then press that negative key. What that does is that it's going to do 0.1275 divided by my previous answer. And so that's how I got that without like typing in all those like weird numbers all over like repeatedly. Okay, so looking back to our problem, we just have one more here. For number 3, if the company president demanded a 99% confidence instead of 95% confidence, with that, you would need a larger sample size to be more confident. You would have to check more signatures. All right, we're done with part 4. Finish that up and then tune in for part 5.